Hello everyone and welcome to the latest installment of the IGCSE 0580 Solution Guide series. In this video we will take a closer look at paper 2.1 from the October-November exam period of 2020. So without further ado, let's dive straight into it. So exercise number 1 requires from us to simplify the expression 3a plus 7b minus 4a plus b. And what we simply got to do here is to add up or subtract apples and oranges. So in this instance, this means that we just need to calculate 3a minus 4a, which equates to negative a. After that, we just add up 7b plus b, which equals to 8b. And that's all that's to it here. In exercise 2, we should use a ruler and a compass in order to complete the scale drawing of field ABC, where the side AB has already been drawn for us. In this case here, the scale of 1 centimeter represents 100 meters in reality. So in order to draw our triangle to scale, we need to bring the length of AC as well as the length of BC down to scale. In order to do that, we just divide those two expressions by 100. In doing so, we receive 5 after dividing 500 by 100, and 6.5 for BC after dividing 650 by 100 as well. These two lengths represent the respective diameters that we need to apply while using our compass. After doing that, our two circle lines will intersect in point C. After doing so, we just connect the intersect with their endpoints in A and B respectively. Moving on to exercise 3, Rangan buys 3.6 kilograms of potatoes and 2.8 kg of leeks. The total cost is $13.72. Leeks cost $2.65 per kilogram. Find the cost of 1 kilogram of potatoes. In order to find the solution, we need to use a system of equations. We received the first equation in looking into the first two sentences of the exercise, where it stated that 3.6 kilos of potatoes plus 2.8 kilos of leeks make up for a total cost of $13.72. The second equation can be derived from the final sentence, where it states that leeks cost $2.65 per kilogram. In order to solve this system of equations, we then substitute our expression from the second expression with L in the first expression, after which we then receive the expression 3.6p plus 2.8 multiplied by 6.65, which still equals to 13.72. In the next step, we isolate 3.6p from the rest of the equation. In order to receive p, we then just divide this entire expression by 3.6, and after entering all of those numbers into your pocket calculator, you will derive to the solution that 1 kilogram of potatoes costs $1.75. Next to exercise 4, Aisha records the distance she runs and her average speed. The results are shown in the scatter diagram. We'll look at this here. Exercise A, the table shows the results of 4 more runs, and in order to plot these points, we just need to keep in mind that on the x-axis the distance is represented, whereas on the y-axis the average speed. To doing so, we should receive all of those points here that are color-coded in purple. Exercise B wants for us to determine the correlation that is shown in this scatter diagram. As we can see, all of those points inside of this diagram follow a downward trajectory, which means that the correlation is negative. Exercise C requires from us to draw a line that best fits the scatter diagram. One way to do it would be to take the point at the top left corner and connect it to the one that's just in between those 3 points. Finally, we should use our line from C in order to estimate Aisha's average speed when she runs a distance of 6 kilometers. In order to do so, starting from here, we just move vertically upwards until we meet our line. And as we can see, it roughly meets at about 11 kilometers per hour. In exercise 5, we should work out an estimate for t by writing each number to one significant figure. So starting from the top left to the bottom right, 49.2 rounded to one significant figure equals 50. Since 9 is larger than 4, so we are required to round up. So 49 rounded up equates to 50. As for the second number, as we can see, the second digit is 5, which again is larger than 4, so we need to round up 9 to 10. Continuing with 4.085, the second digit is 0, which is less than 4, which means we need to round down, which gets us 4. And finally, taking a look at 2.35, our second digit here is 3, which is less than 5, thus we need to round down to 2. And from here we just simplify the expression. 50 minus 10 equals 40, and 4 multiplied 2 equals 8, and this simplifies to 5. In exercise 6, we should work out the expression 2 2/3 multiplied to 3/4 without using a calculator, and we're required to show all of our working. While providing an answer as a mixed number in its simplest simplest form. So starting from the top, we convert the mixed numbers into improper fractions. As per the rule, the denominators remain the same and we are receiving our numerators in multiplying the respective whole numbers with their respective denominators. So in this case, 2 multiplied 3 equates to 6, and at the end we add the given numerator. So 6 plus 2 equates to 8. The same accounts for this mixed number, so 2 multiplied 4 equals 8, and after receiving that number we just add 3 to it, and 8 plus 3 equates to 11. In a second step, we can simplify this expression in dividing 8 by 4, which equates to 2, and thereafter we multiply the numerators and denominators respectively, which leads us to the improper fraction of 22 over 3. As we cannot simplify this expression further, we now provide the answer as requested as a mixed number in its simplest form, and as we know, 3 fits exactly 7 times into 21, which leads us to the result of 7 1/3. In exercise 7, we should make x the subject of this formula. So in step 1, we isolate x from the rest of this formula, which we could, for example, do by adding both sides of the equation with 7, after which 5x equals 2y plus 7. And finally, in order to determine x, we just divide both sides of the equation by 5. In exercise 8a, 1, 2, 3, 5, and 7 are all common factors of two numbers, and we are required to write down the digit that the two numbers must end in. In this specific case here, we need to keep two things in mind. Number 1, except for 1, all of the other numbers are prime numbers, and in order to determine common factors, the number 1 can technically be ignored. So starting from there, we just multiply all of those numbers and receive 210. And the last thing we got to remember here in order to provide the correct answer is that any number that is multiplied by 0 equals again to 0. So whatever we multiply 210 with, the final digit will always be 0. In exercise B, we are required to write 84 as a product of its prime factors. As we can see, 84 is an even number, which means that we can safely divide it by 2. So we can derive from there that 82 equates to 2 multiplied 42. Now we just take a look at 42, and obviously it's an even number again, which we can divide by 2. 21 remains. 21 can be divided by either 3 or 7, since 3 multiplied 7 equals 21. Both of those factors are prime factors, so we can stop our calculations here. In exercise 9a, we need to perform a percentage change, as Ahmed intends to increase 40 by 300%. In order to do so, we take Ahmed's 40 and multiply it by the expression inside of the parentheses. From there we simplify 300 over 100, which equates to 3, and after that we just simplify the sum within the parentheses, which equals to 4. And taking a look at all of the options provided, we can clearly state that 40 multiplied 4 is the correct solution. We can calculate this percentage change with the help of the formula that will be provided to the right-hand side of the screen. In B, Ahmed intends to find the magnitude of the vector 2, -3. As with the previous exercise, it is possible to easily calculate the magnitude of the vector with the formula provided on the right-hand side of the screen. After applying the formula to this vector, we come to the conclusion that the final option provides us with the correct solution. Moving on to exercise 10, a town has a population of 45,000. This population increases exponentially at a rate of 1.6% per year. Keywords here are exponentially at a rate of 1.6% per year, which means that we are dealing with exponential growth. The formula to calculate exponential growth will be provided on the right-hand side of the screen. So in order to use the formula, we need 3 pieces of information. Number 1, the starting population. Number 2, the rate of growth. And finally, the time span. After inserting all of those information into the formula provided, we will receive 48,717 as a solution. Keep in mind though that we are required to state the answer to the nearest 100. So taking a look at the final 2 digits, 17. 17 is less than 50, which means that we need to round down and receive 48,700. Moving on to exercise 11. Given is a diagram that shows a rectangle with a line of symmetry at x equals 2, as well as 2 vertices of the rectangle at -1, 1 and -1, 4. The shaded region is defined by the inequalities provided in the question paper, and following from there we are required to find the values for a, B, C, and D. A and B are found parallel to the x-axis. The values of C and D can be found along or parallel to the y-axis. In order to find the value for A, we just need to take a look at the left outer boundary of this rectangle, and from there take a look at the x value of the points that are given, which in both cases are -1. Please keep in mind that whenever a point is given, the first figure will give us our x value and the second one our y value. Since there is no value within this shaded area that is lesser than -1, -1 is our solution for A. Getting the value for B is the trickiest part of this exercise, since we first need to determine the distance between the symmetry line and A. So since the symmetry line can be found at x equals 2 and the value for A is -1, the distance can be calculated by 2 minus -1, which equals to 2 plus 1, which then equals 3. Since the right-hand part of this rectangle is a mirror image of the left-hand part, we just need another 3 to 2, and after adding both numbers up, we receive 5. Now, it can be argued that receiving the values for C and D is the simplest part of this exercise, since we just need to take a look at the y values of both of the points that are given in the exercise. From there, let's move on to exercise 12. The interior angle of a regular polygon with n sides is 156 degrees. In order to find the correct solution here, we need to apply this formula here, 180 multiplied n minus 2 divided by n standing for the sides of the regular polygon. From there, we need to calculate n. In order to do so, in a first step, we multiply both sides of the equation by n. Afterwards, we expand the expression 180 multiplied by n minus 2. In a third step, we isolate n, and we do this by subtracting 156n on both sides of the equation. In a final step, we divide both sides of the equation by 24 and receive 15 as a result for this exercise. 13 requests from us to write the recurring decimal as a fraction in its simplest form. We must show all of our working. In order to do this successfully, we need to split up the recurring decimal into two parts, into non-recurring decimal and into a recurring decimal. From there, we will attempt to convert both of those numbers into fractions. 0.1 is then converted into the fraction 1 over 10. The latter half of the expression can be converted to 0.1 multiplied by this expression over here, whereby 0.1 can then be easily transferred into the fraction 1 over 10. In the last step, we need to convert this part into a fraction as well. And as we should know, for recurring decimals, the denominator will be 9, and the recurring decimal becomes the nominator. From there, we multiply those two fractions, whereafter we need to add those up and make sure that both fractions receive the same denominator, which in this case is 90. So we just multiply the numerator and denominator by 9. And after simplifying this expression, we derive to the conclusion that our fraction can be simplified to 8 over 45. In exercise 14, we should find the gradient of a line that is perpendicular to 8y plus 4x equals 5. In order to do so, we need to transform this expression into the so-called slope-intercept form. So what we need to do from here is to isolate y. We can achieve this by, in the first step, subtracting 4x on both sides of the equation, which leaves us with the expression of 8y equals to -4x plus 5. In a final step, we divide both sides of the equation by 4. Finally, in order to find the gradient, we just take a look at the number that's in front of the argument x. So the gradient of a line that's perpendicular to this expression is -1 over 2. The gradient of this line would be -1 over 2, but this is not our result yet, since we were asked to find the gradient of a line that is perpendicular to the given expression. To achieve that, we will apply the formula that is provided to you at the right-hand side of the screen. In exercise 15, we are faced with a diagram that shows the speed time graph for 100 seconds of the journey of a car and a motorbike. And in A, we are required to find the deceleration of the car between 60 and 100 seconds. To do that, we take a look at the interval between 60 and 100 seconds and calculate the change in height and divide it then by the change in horizontal distance. This can conveniently be achieved through the application of the formula that helps us in determining the slope between 2 points. So after inserting the points 106 as well as 60, 18, into the formula, after processing those numbers with the help of your pocket calculator, you should receive -0.3 as your answer for this question. In exercise B, we should calculate how much further the car traveled than the motorbike during the 100 seconds. Now, in order to calculate how much further the car traveled than the motorbike during those 100 seconds, we need to first calculate the area of this rectangle, which is represented by this expression 6 multiplied by 60. That time period within those 100 seconds where the motorbike went further than the car. One could also determine from pure observation that those two areas are exactly the same. Thus we could simplify this entire expression in only determining the area of the rectangle in order to determine the right answer. What follows is exercise 16, where we have to factorize the expression 6x squared plus 7x minus 20. And in order to do that, we can determine the factors by employing this formula here. After expanding this expression, we can then determine the makeup of each of those coefficients. Hence, all of those equations to the right then apply, and after an educated mixing and matching of all of the factors a, b, c and d, we will then be able to determine this exact expression here. In exercise 17a, we got to determine the value of the constant a of this quadratic function. In order to do so, we can exploit the information that in x negative 2, the value for y equals 19. And in order to exploit that piece of information, we replace x with negative 2 and f of x with 19. In a second and third step, we simplify the equation until we get our value for a, which in this case equals 7. Exercise 17b1 explores composition functions. In this case, the functions g and h are given, and we need to determine g of h of x in its simplest form. To do that, we substitute the variable x in g of x with h of x, which equals 3x minus 8. And after this is done, we firstly expand the equation to then simplify it in the final step. So our solution for this exercise is 6x minus 9. In part 2 of exercise 17b, we are required to find the inverse of g of x. To do that, we transform g of x so that x becomes our argument. And in the final step, we replace x with y and vice versa in order to determine the final result. Next, let's move on to exercise 18. So this diagram shows a solid made from a cylinder and a hemisphere, both of radius 7 centimeters here and there. The cylinder has a length of 12 centimeters. So here we should work out the total surface area of the solid. Surface area A of a sphere with a radius r is A equals 4 pi r squared. In order to solve this task in the most efficient way, we need to perform 3 separate calculations. Firstly, we could determine the surface area of the bottom surface, which is nothing more than a circle, and we need to determine thus the area of this circle. And this is done through the application of the formula r squared multiplied pi. In this case, r equals to 7, thus the area of the bottom surface equals to 49 pi. Second, we take a look at the shell surface of this rectangle. In order to determine the shell, we need to multiply the height of the cylinder with the circle line of this circle here. To determine the circle line, we need to calculate 2 pi multiplied the radius, and this 12 represents the height of our cylinder here. After using our pocket calculators, we should arrive to the result of 168 pi. Finally, we need to determine the surface area of the hemisphere on top of the solid, and for this we can employ the given formula in this exercise, which states that the surface area of an entire sphere equates to 4 pi multiplied r squared, and we just replace r with the length of the radius, which still is 7. After doing so, we divide our result by 2, since in this case we just need to determine the surface of a hemisphere and not of an entire sphere. The size of that surface area equates to 98 pi. In order to determine the surface area of this entire solid, we just add up all of those 3 areas that we previously determined. Exercise 19 requests from us to shade the region that represents the union of not M with the union of N and P. To do so, we can firstly shade the region that represents not M. In this case, I've colored this area in green. In a second step, we can determine the union of N and P, which is represented by the area that's shaded in blue. So our final results is represented by everything that is shaded in those 2 aforementioned colors. In exercise 20, we are presented with a diagram that shows a cyclic quadrilateral, and the goal for us is to find the value of y. To do so, we need to keep in mind that in a cyclic quadrilateral, opposite angles equate to 180. So our first keyword here is cyclic quadrilateral, and as we know, the sums of all of the angles in each quadrilateral add up to 360, which is represented by this equation over here. So we got our 2x plus 4x minus 87 plus x plus 60 plus y. Since we are required to find the value of y, we will transform this equation until we receive this expression here at the bottom. The problem with this expression here is that we need to find a way on how to eliminate the variable x. In order to do that, we can make use of this piece of knowledge here, and it makes use of the following. In every cyclic quadrilateral, opposite angles add up to 180. The easiest way to do it in the exercise would be to take a closer look at those two angles over here, since both angles contain the argument x. Trying to do so with those two angles would not lead to a result, as there would be no way for us to substitute x. So here we can establish the equation that 2x plus 60 equals 180. We add up the x's and isolate them to finally determine that x equals to 40. Finally, we substitute 40 for x in the first equation, and after doing so, we will derive to the conclusion that the value for angle y equals to 107 degrees. In this exam, there are 3 more exercises to go, so let's take a quick glance at exercise 21. This diagram shows us a cuboid PQRSTUVW, whereby the length of PV is 17.2 centimeters. PV in this case represents the space diagonal of this cuboid, and we are required to calculate the distance PT. The easiest way to do this is by employing the rectangular triangle that I have written into this cuboid, whereby the distance, aka our space diagonal, represents the hypotenuse of that triangle. Furthermore, we know that the angle between the line PV and the base TUVW of the cuboid is 43 degrees. So in order to calculate the distance PT, we could employ the sine rule. So in order to calculate PT, we can explain all of this information by knowing that in every rectangular triangle, that the opposite divided by the hypotenuse equals 2 sine, in this case sine 43. We then multiply this equation by 17.2 in order to isolate PT, and after putting all of those numbers into our pocket calculators, we should arrive to the solution that the distance of PT equals to 11.73 centimeters. We have now arrived at the penultimate exercise of this exam paper. In exercise 22, we are required to simplify this expression. So in order to do so, we need to factorize the numerator as well as the denominator by employing our knowledge of binomial formulas, which you will find at the right hand side of the screen. So firstly, after taking a look at the numerator, we can see that x squared as well as negative 5x contain x, so we can factor x. And in the denominator we can factor 2, since 2 as well as 50 can both be divided by 2. Furthermore, we should be able to see that the expression x squared minus 25 can be factorized employing the third binomial formula, which states that a squared minus b squared equals to a plus b multiplied a minus b, whereby in this case a is represented by x and b is represented by 5, since the square root of 25 equals to 5. In the final step, we can see that the numerator as well as the denominator have a further common factor, which is x minus 5. So after simplifying, we get our result, which is x over 2 multiplied x plus 5. Next on to exercise 23, where it's all about vectors. In A, we are provided with a diagram that shows us a parallelogram CDEF, whereby vector FE equals m and vector CE equals n. B represents the midpoint between C and D. Furthermore, the distance FA is twice as large as the distance between A and C. We are supposed to find an expression in terms of m and n for vector AB, and we should provide the n's in its simplest form possible. So first, in order to get from A to B, we need to get from A to C and from C to B in order to reach point B. In a second step, we can replace the expression vector AC with 1 over 3 vector FC. The reason behind that, as stated here, the distance between F and A is twice the distance AC, so AC technically consists of 3 parts, whereby AC is 1/3 of the distance of FC. Secondly, CB can be replaced by the expression vector FE, since both vectors are parallel to each other, and as B represents the halfway point between C and D, we can conclude from there that CB represents 1 over 2 vector FE. In the next step, we substitute vector FC with the expression m minus n. In order to get from F to C, we can go from F to E, which is m, and from there we move on to C. Just be careful here, don't make the mistake of adding up m and n. The reason being that the orientation of this vector goes from C to E and not the other way around. So since we are reversing the orientation, we need to change the sign from plus n to negative n. Vector FE can be substituted by m, as stated in the exercise. From here we expand this expression, add up all of the corresponding variables. In order to add those two components up, we need to find the lowest common factor, which is 6. From there we arrive to the conclusion that vector AB can be represented by the expression 5 over 6m minus 1 over 3n, as requested by this exercise. We have now arrived at the final exercise of this exam paper, exercise 23b. Here we are presented with two vectors, namely vector GH and vector JK, and we are supposed to write down two facts about those vectors. Fact number 1 would be that both vectors are parallel to each other, since both move into the same direction, 2p plus q. The only difference being would be the coefficient of those vectors. So what we need to do is to make those comparable in finding the least common factor in terms of the denominator, which would be 18, since 6 fits 3 times into 18. And from here we can see that the coefficient of vector GH is larger than that of vector JK, which means that vector JK possesses a greater magnitude. I've been your host Marco from PlanetMaths. Should you derive any value from my videos, please consider to leave a like, comment and subscribe. Thank you for watching. Cheers.